Length of cross product. We know how to compute a cross product, and we also know how to determine the direction of a cross product of two vectors, relative to those vectors. However, we do not have a formula for the length of a cross product. Of course, if we compute the cross product, we can then compute its length by using the formula for the length of a vector. But there is another formula for computing the length of a cross product. It turns out that the length of A cross B is equal to the length of A, times the length of B, times sine theta. Here theta is the angle between the vectors A and B, and recall that by saying angle between two vectors, we mean the one smaller than 180 degrees. Now suppose we have the vector A equal to 101, and the vector B equal to 111. Let us try to compute the length of their cross product using the two methods. In this case, as we are given the vectors, of course, the easiest would be to use the first method and so compute their cross product and then the length of it. So here 101 cross 111 gives us minus 101. And so, we have the length of it is equal to square root of the sum of minus 1 squared, 0 squared and 1 squared. We get the length of cross product of A and B is equal to square root of 2. Let us now use the new method of finding a length of vector product. Here we get the length of 101 cross 111 is equal to the length of 101, times the length of 111, times sine theta, where theta is the angle between the two vectors. Obviously, the length of 101 is square root of 2, using the length formula. Similarly, the length of 111 is equal to square root of 3. We are left to find sine theta to determine the length of the cross product. Here on the right we have the vector A and the vector B and the angle theta between them. To find theta, we can apply the dot product formula A dot B is equal to the length of A, times the length of B, times cosine theta. Here we know the length of vector A is square root of 2 and the length of the vector B is square root of 3. We can also quickly find the dot product of the vectors and B, which is equal to the dot product of 101 and 111 and so gives 2. Therefore, cosine theta is equal to 2 over square root of 6. We have cosine theta and we need to find the sine theta. We may use the fact that sine squared theta plus cosine squared theta is equal to 1. From here, sine theta is equal to square root of 1 minus cosine squared theta. Note that the sign here is positive, as theta must be less than 180 degrees. So, by simplifying, we get sine theta is equal to 1 over square root of 3. We now have sine theta is equal to 1 over square root of 3. Then, the product becomes square root of 2, times square root of 3, times 1 over square root of 3. And so, we get square root of 2 for the length of A cross B. Notice that we got the exact same outcome using the two different methods.